So ranking things can kind of be tricky, especially when they're going back and forth between acids and bases. So in here, we're asked to rank the weakest base all the way to the highest. And remember, pH, it works kind of like this. The lower your pH, the stronger your acid. The higher your pH, the weaker your acid. So if they're asking us to rank from 1 through 8, where 8 would be our highest pH, and that would be our most basic, and this right over here would be our weakest base. So in order to do this, we need to understand something about how acids and their conjugates work. So since we are trying to do a scale going from lowest to highest right here, what we're going to do is we're going to say that the strongest base will be a number 8. Remember, we're not actually writing the pH, but that's the strongest base. The weakest base down here, that would be a 1. Now, flipping it around, we know that if we were to do the conjugate of those things, these are the conjugates of these guys over here. These are the conjugate acids, right? The stronger our base, the weaker our acid. So as we go down, as our bases become weaker and weaker, our acids become stronger and stronger, right? So what they're doing is they're actually cutting this right across the middle, and they're giving us 4 bases and 4 acids. So if we can number 8 down through 5, then we're going to know simultaneously what 4 through 1 is. Yeah? So let's go back up to our top right here, and let's take a look at what they've given us to start off with. Now, they've given us what the strongest base is right here. They've given us that it is OH. So what I'm going to do is I'm going to make our little table here, and at the very top, my strongest base is going to be OH minus, and we're going to give that a number 8. Now, whatever's corresponding to it, it's conjugate base, and if we take a look, this is my base, and this is its conjugate acid. Yeah? So if we take a look over here, the opposite is happening right here. So whatever our strongest base is, that's going to be our weakest acid, which is going to be H2O. And remember, H2O can actually be considered an acid, but it's not going to be very strong. And because this is going to go down from on this side from 8 down to 5, here we're going to start at 4 and go down to 1. So H2O is a 4, OH is an 8. Now, then let's look at the next one. Here we have BRO minus, and they tell us the BRO minus is a 7. So that means that its conjugate is going to have to be the next strongest acid. Remember, the weaker your acid, the stronger your conjugate base. The stronger your base, the weaker your conjugate acid. So in this case here, this is a little bit weaker of a base than this is. So then the conjugate, HBRO, is going to end up being a 3. Now, after BRO minus, we have to take a look and see what the heck is next. So if we take a look on our table, we have a few other choices for bases. And one of the things we can do with bases, we can look and see the things that are negative, those are going to be bases. We've not figured out this one, CLO minus. And we have yet to figure out our 4 over here. But if we take a look at our CLO and our CH3COO minus, we have to determine which one of these two is the weakest. Now, we can talk about how induction impacts pH strength and acid strength, but we're not going to do that right now. We're just going to look at these two right here, and they tell us that this is a 5. So that means that down here, right here, we're going to have to put our CH3 COO minus. It's going to be the weakest of the bases. And by default, that means therefore that its conjugate acid has to be the strongest acid. So over here, I didn't leave very much room for it here, but over here, we're going to have to put our CH3 or CHCOO, CH3COOH, our CHCOO there. So the only thing that's left in between here is our CLO minus. Now, by default, since we have 1, 3, 4, and 8, 7, 5, that ends up being our middle 6 right here, and its conjugate over here, HClO, is going to end up being our 2. So when we go through our numbering system here, we have H2O, that right here is going to be a 4, and we're going to put that in right here as a 4. Our ClO, we've just discovered that that is a 6. So we're going to put that in over here as a 6. We know our 5, 8, 7, our Chiku over here, that ended up being the lowest pH or the strongest acid. So we're going to put a 1 right here. And then finally our HBRO, which is this guy right here, is going to be a 3. Now, let's just say we didn't have this table and we were comparing all these guys to each other. One of the things I want you to pay attention to is this. Whenever we're dealing with weak acids, the more oxygens you have on that acid, the stronger you are. So if we take a look at this, Chiku, and these are our 4 acids that we're comparing each other to. And would you note here that the CH3, this guy right here, has 2 extra O's that are pulling electrons away from this hydrogen, and therefore it has to be the number 1, the strongest. Now, H2O, we can probably surmise, is neutral, and it's not a very strong acid. So then we have to compare these two with each other. And here they look almost identical. You have HClO and HBRO. But of these two right now, we know that Cl is more electronegative than Br. So therefore, this would be the second highest, and this would be the third. So it goes 1, 2, 3, 4. So even if you didn't have the chart to work with, you could probably figure it out based on induction, which we unfortunately are going to cover a little bit after this. Hopefully this has been helpful.